Hello everyone, welcome to this video where we are going to dive into minimize XOR. So basically what is happening here is that you receive as input two numbers, nums1 and nums2, and then you need to find a positive integer x such that x has the same number of set bit with num1 with num2, and the value of XOR num2 is minimal. So how are we going to solve this? So for us to solve this, what we are going to do is that we are going to find out what make the XOR of 2-bit integer, what can make the XOR of 2 integer minimal. What is the procedure or the flow of constructing an integer x in such a way that the XOR with num1 will be minimal? Once we'll be able to find this, we are now going to use the number of bit set of the num1 to construct this integer. So let us dive into understanding how to make the XOR of 2 number minimal. For that, we are first going to understand what is a XOR. So if you want to make the XOR of this and this, you are going to have this as answer. Why? Because the XOR of two numbers that are actually equal, that means 1 and 1 is 0, 0 and 0 is 0. But the XOR of 1 and 0 is 1, and 0 and 1 is 1. So 1, 1 is also 0 here. So this is it. So if I have, let's say I have this number for initial, I would say, consider this as empty space. If I want to construct a number like this with 2-bit, let's say 2-bit, with 2 1, and I want this to be minimal. Given that I know that 2 bits that are actually equal will give me 0. For me to construct this to be minimal, I will check wherever there's a 1, I will put a 1 until moving from left to right. So what will happen is that here I will have a 1. Here I will do nothing because I have a 0 here. Here I will have a 1, and then I've used all of my bit set. So the XOR of those of this and this will give me a 0 here, it will give me a 0 here, it will give me a 0 here, and it will give me a 0 here. This is the minimum possible value we can have using a bit set of bit set of 2. But now let's say now you want to use a bit set of 3 instead. What will happen is that you are going to fill it this way. You fill from left to right. Wherever you have a 1, you put 1 on the number you are constructing. Now that you have moved from left to right to the end, you still have one bit set that you need to use because you wanted to use 3. Now you will move from right now to left, and then you are going to transform the 0 into 1. Why are you doing that? Because you need to add bit set, right? Because you have bit set left, and then if you move from left to right, you are going to maximize it, because changing this one instead of this one will make you have 1 0 0 0 instead of 0 0 0 1. So that is why for us to construct x in such a way that the XOR of nums1 and x is actually minimal, the first pass we are going to do is to set the 1. Like we just said, the first pass is that we are setting the 1 from left to right, and then now we are setting the 1, if we have a remaining element, from right to left, and at the end we are going to have a number that will be used as x. So that will be the approach of solving this. Now how are we implementing such approach? You can transform. So there's one thing I didn't explain, is where are we getting this number, the number of bits we want to use to construct x. So we said that x has the same number of set bit with num2. So the thing you're going to do is that you are going to get the number of bit of num2 and use that to construct x. So you can use an array if you want. That means you use an array with 32 bit, because you know that x will not go above 32 bit. and then you do the operation of looping and comparing. In my case, I will use bit set manipulation. I do believe that you'll be able to implement the array solution. If you're stuck with that, you can share your solution in the link and we can discuss about it. Me, I'm going to use bit set because I definitely think that it will be interesting for you to know how to use that for such situation. So the first thing we are going to do is to get the number of bit set of num2, which is something we are going to do like this. I will call it count. It's actually the bit set operator I'm going to use of 32-bit of num2, and then I will count. Yeah, so this is all you need to do to have the count, the number of bit set of num2. Now that I have the number of bit set of num2, what I need to do is to construct my x. So I have int x equal to 0. I'm initializing it at 0 for me to have the structure, and then now I need to look from left to right to add the 1, and from right to left to continue adding the 1 if I have some left, and then I just return x at the end. So at the end, what I will do is I will return x. I don't need the space because there's nothing I will add here. Now I need the first for loop. So the first for loop will be like this. I'm moving from this is moving from left to right. So from left to right, I'm moving from 31. X is I is actually greater or equal to 0. I minus. So why am I using 31? Because this is the limit. The limit is actually 10 power 9, and then it can definitely fit into 31 bit. Yeah. So if you try to convert this, I think it's something with 30 bit. If you convert this into binary representation, it's something like 30 bit. But it is actually 31 bit is enough to handle all of the number of the constraint. That's why I'm using this. You can even use 31 here. Okay, so now that I'm looping, what am I doing? I will check if it is a 1. So what I will check if it is a 1 on the nums1. To check if there's a 1 on the num1, you can use if 1 left shift, I think it's right shift, I don't know, of I, and single and nums1 is actually different from 0, and if we still have some count left. Okay, so what I'm doing is, okay, I'm taking maybe a number like this. I'll take like a number like this. Oh, let's say you have a number like this, 1 0 0 1 1. If I want to check if there is a 1 here, this is 1 2 3 4. That means there's the 4 digit before the 1. So I will create a number. The left shift I'm doing 1 left shift of I, it will do something like 1 and create 0 0 0 0 like this. And if I do the AND of those two, of this element, of those two numbers, it will give me a 1 here and 0 0 0 here, and I have a result which is different from 0, then it is a 1. But in the other hand, if I create a number like this, 1 0 0 0, and I do the AND, it will give me 0 0 0 0 0. You see that I have a 0, that means there is a 0 here. So you just create a shift with the number and you fill the 0 all over from the position to the end, and then you do an AND. If the AND return you 0, that means there's a 0 at that position. If the AND return you 1, that means there's a 1. If the AND return you something different from 0, that means there's a 1 at that position. That is why I'm doing it here. And when there is a 1 and then I have enough bit set left, what am I going to do? I'm going to add 1 at that position, and to add that position is actually adding this, because keep in mind that if I want to add 1 here, I can just make this number plus this number, and this is the number I just generated for the check. So I can just do something like x plus equal to 1 shift of I. That is it. That's all what we need here. And then after doing this, we just need to keep decrementing the count. We are going to do exactly the same for the left to the right pass, just that we are changing a couple of things here. I is now moving from 0, I is greater or equal to 31, and then I plus plus. We are doing the same check because we are checking for if we have a 1, and then we are adding the same value and we are decrementing the count. But now we are not checking if we have a 1. We are checking if we have a 0. In the first pass we are checking for 1. Now in the second pass we are checking for 0 to fail, and then we want to start with the leftmost one. Okay, I think this will be all to solve this. You get the number of bit count, you fill X from right to left, searching for 1, you fill X from left to right, searching for 0, and then that is all. Let us run. Okay, we have a wrong answer. I'm missing something somewhere. Oh, so you need to really be careful with the you need to be really careful with the priority of the operation you are making. So we have an AND here, we have a 1 here. I will rather have a double element here and then here. I'm doing the same here. Yeah, it's working. So without this, actually what will happen is that it will mess up with the priority. So let us run and see what it gives. Nice, performing pretty well. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. Don't hesitate to try to implement this using array, and definitely sure that you have the same result. Keep learning. Let's see on the next video.